Quantitative aptitude 1, fourth topic it is LCM and HCF. Before going to see this video, first you go through the 3 topics. It is Vedic mathematics, square, square root, cube, cube root and higher roots. This is the fourth topic, LCM and HCF. I will discuss with you in detail from very basics. What is LCM, what is HCF, what are the applications of LCM, what are the applications of HCF, what is the relation between LCM and HCF. Each and every point I will discuss with you. So in this topic, so actually in the lower classes you learnt about LCM. All of you know about LCM. What is LCM? LCM means least common multiple. So what is LCM? LCM means least common multiple. It is. LCM means least common multiple. Least common multiple. First, I will discuss with you what is the definition of LCM it is. So, least common multiple. I took one example. Let it be LCM of 2, 3 and 4. LCM of 2, 3, 4. According to the definition, how can we say? Now, for the given values, you have to take multiples here. Multiples. What are the multiples of 2? What are the multiples of 3? What are the multiples of 4? So for any number, there are infinite number of multiples it is. What are the multiples of 2? 2 into 1, 2 into 2, 2 into 3, 2 into 4 and so on up to infinity. What are the multiples of 3? 3 into 1, 3 into 2, 3 into 3 and so on up to infinity. For any number, if you take, there are infinite number of multiples are there. Now here LCM of 2, 3, 4 means you have to take the multiples of 2, multiples of 3 and multiples of 4. Now see here, what are the multiples of 2? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 and so on it is. Infinite number of multiples are there. Similarly, what are the multiples of 3? So 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36 and so on it is. Infinite number of multiples are there. Now similarly, the multiples of 4 you have to take. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44 and so on it is. Now in the multiples, what you take? The common multiples. Common. So what are the common multiples? By observing here, 8 is not common. So 12 is common here. By observing here, so 12 is common. Now what is the next common multiple? 24. Now what is the next common multiple? 36. Just like if you observe the common multiples also infinity. Common multiples also infinity are there. Now in these common multiples, what we require? What we require? The least one you require. What is the least one? 12. So simply we say LCM is equal to 12. That is the exact definition of LCM. For the given numbers, you have to take the multiples. In the multiples, observe the common multiple. In the common multiples, you have to take the least one, smallest one. That gives the LCM. But generally, we don't follow this method to calculate the LCM for the given values. Why? Suppose the larger values is given. Suppose 120, 140, 160. So you have to take the multiples of 120, multiples of 140, multiples of 160. It takes a lot of time to write and also a mental stress to calculate. So generally, we don't follow this method, but it is the exact definition of LCM. But how can we calculate the LCM for the larger values? So division method is there. So according to division method, we can calculate the LCM. See here, what is the division method? I will explain. So what is the division method? Now in division method, so you have to put one point. What is that point? Divide the given numbers with the prime number only. That is very important. So divide the given numbers with the prime number only. But which prime number you have to take? There are infinite number of prime numbers again. What is meant by prime number? It is divisible by 1 and itself only. First prime number is 2. Next prime number is 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37. Just like infinite number of prime numbers are there again. But which prime number you have to take? That prime number divides at least 2 given numbers. So which prime number you have to take? That prime number divides at least 2 given numbers. Observe the example, you can understand very easily. What is the division method? Suppose let it be LCM of, I will take the simple values 5, 10, 15, 20. What is the LCM of 5, 10, 15 and 20? Now take the numbers 5, 10, 15 and 20. Now divide these numbers with the prime number only. But which prime number? That prime number divides at least 2 given number. So you take 2. 2 divides 10 and 2. Okay, or 5 you take. 5 divides all the numbers. So anyone you have to take either 2 or 5. So I will take the 5. So 5 ones, 5 twos, 5 threes, 5 fours it is. Again take the prime number. That divides at least 2 numbers. Now we take 2. 2 ones, 3 is not divisible. Take as it is 2 twos. Now again take the prime number. That divides at least 2 numbers. Now if you take 2, that divides only 1 number here. If you take 3, that divides only 1 number here. So there is no prime number which divides at least 2 numbers now. Stop up to this and take the product of the last divisors. Take the product of this last divisors now. So 5 into 2 into 1 into 1 into 3 into 2. How much its value? 5 2 is 10, 10 3 is 30, 32 is 60. So what is the LCM? 60 is the LCM. So this is the division method to calculate the LCM. So in the division method, what you do? You have to divide the given numbers with the prime number only. But which prime number you have to take? That prime number divides at least 2 given number. That strategy you have to follow. So I will explain one more example. Okay, suppose let it be, what is the LCM of LCM of 10, 15, 20, 25. So how can we calculate the LCM? You take all numbers 10, 15, 20, 25. Now what you do? Divide the given numbers with the prime number only. Which prime number you have to take? That prime number divides at least 2 numbers. Here also you have to take either 2 or 5. Both are correct. Anyone you have to take. I will take 5 here. Now by dividing 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25. Again take the prime number. So take 2, 2 1s, 3 is not divisible, 2 2s, now 5 is not divisible. Again take the prime number that divides at least 2 numbers. Is there any prime number? No. If you take 2, that divides only 1 number here. If you take 3, that divides only 1 number. If you take 5, that divides only 1 number. So there is no prime number which divides at least 2 numbers now. Stop up to that and take the product of the last divisors. Take the product of all this now. That gives the LCM. 5 2s are 10. Okay, 5 2s are 10. 10 3s are 30. 30 2s are 60. 60 into 5. 300. That is the LCM. Understood? So in division method, how can you calculate the LCM it is? Okay. So in the next class, I will discuss with you the continuation of this LCM and HCF. Thank you to all of you.